You don't want to learn how to use Desmos, you want to learn when to use it. Everyone thinks that they know how to use Desmos, and you probably do. I mean, you just type in numbers into a box and boom, a graph appears. But today I'm going to walk you through some of the must-know questions that you should really use Desmos for to get through the SAT math section much faster. Not to mention, the probability of you getting the question right is also going to increase. My name is Krishna, and I'm the founder of Future Admin, and we've helped students from 22 plus countries earn their dream score. Okay, so situation 1 is when we're solving for points when not given an equation. So for example, this question says, in the xy plane, line J intersects the y-axis at point 0,2 and passes through the point 1,5. If the point 2x lies on line J, what is the value of x? Okay, so we're trying to find the value of x, but we're not given the equation of the line, but we are given 2 points on the graph. So instead of using point slope formula, we can just simply plug in both of these points into Desmos and then get an approximate equation of the line. So for example, if you go to Desmos and then you click the plus button and then you click table, a table is going to appear with x1 and y1, and now we can just put in the 2 points that we know, 0,2 and 1,5. Now, under the table, we want to basically just write y1 and then a little squiggly, mx1 plus b. Now, to get that little squiggly line notation, you can look for it to the right of the number 1 on your keyboard, or on Desmos, you can just click the keyboard on the bottom left and then click ABC on the bottom left again, and then you're going to see that little squiggly line on the bottom row. So now we have the equation of the line, so now we just need to figure out what is essentially the y coordinate when our x value is 2. So find 2 on the x-axis, then go all the way up. If we go all the way up, you're going to land at the coordinate point 2, 8. So therefore, our x value in this situation is equal to 8. Now you can do this by hand by understanding that 0,2 is our y-intercept, and in our equation of the line, y equals mx plus b, the only thing left to find really is the slope. And we can find the slope because we have 2 points using the slope equation. But if you don't want to do the work to actually find the equation of the line by hand, this is a really simple and easy way to use Desmos. The second time you should really know when to use Desmos is any questions related to system of linear equations. Remember that the solution to a system of linear equations is just where the lines intersect. So the SAT will typically ask you 2 types of questions related to the system of linear equations. They may ask you for the actual solution, which is the coordinate point where those lines intersect, or they may ask you how many solutions do the lines have. Either way, we can use Desmos to figure this out. So for example, this question says, in the xy plane, the graph of y equals 2x minus 3 intersects the graph of y equals 4x minus 4 at the point x, y. What is the value of x? So what we're going to do is simply plug both of those equations into Desmos. Then we're going to find out the exact point where those lines intersect. We can see that they intersect at 0.5, -2. Now the question is asking us for just the x value of that coordinate, so our final answer here is 0.5. This is much faster than solving system of equation problems by hand by using something like substitution or elimination. Now, if the SAT asks you how many solutions does the system of linear equations have, we can also figure this out by just simply looking at the graph and asking ourselves, how many times do these lines intersect? If they never intersect, they have 0 solutions. If they intersect at 1 point, then they have 1 solution. And if it looks like they're the same line, aka they're overlapping each other continuously, that means that they have an infinite number of solutions. The third must-know for Desmos is anything related to quadratic equations, specifically solving for the solutions to a quadratic or the roots themselves, or if the SAT asks you the number of solutions to any quadratic equation, use Desmos. So let's take a look at this problem right here. It says, which of the following is a solution to the equation x squared minus 2x minus 3? So we know that the solutions to a quadratic is where the parabola crosses the x-axis. So all we're going to do is input the equation into Desmos. So we're just going to type out x squared minus 2x minus 3. Now we have a parabola, right? So we just want to look at where this parabola crosses the x-axis. We can see that it crosses the x-axis at -1, 0 and also at 3, 0. So therefore, the solutions to the quadratic are x equals -1 and x equals 3. If we look at our answer choices, x equals 3 is not one of them. So that means D, x equals -1 is the correct answer here. Now, if you're ever asked for the number of solutions to any quadratic equation, then you would follow the same process, right? You would just plug in the quadratic into Desmos and see how many times does this parabola cross the x-axis. If it never crosses or touches the x-axis, then it has 0 solutions. If it crosses or touches the x-axis once, then it has 1 solution. And if it crosses or touches the x-axis twice, then you have 2 solutions. Use case number 4 is when we're solving linear inequalities. So if we want to know what ordered pair may satisfy a linear inequality, we can manually plug in each point and check to see if it's algebraically correct, or we can just graph the linear inequality in Desmos and see if the point lies within that shaded region. So let's take a look at an example. This question says, which of the following ordered pairs x, y satisfies the inequality 3x minus 4y is less than 7? We have 3 points here, 1, 5, 5, negative 5, and 10, 5. So you can absolutely plug in each of these values back into the inequality and see which statement is algebraically correct, or we can just graph this linear inequality here and see which one of these points lies within the shaded region. So if we graph the inequality here into Desmos, you're going to see that the only point that lies within that shaded region is 1, 5, right? 5, negative 5 does not lie in the shaded region, so it does not satisfy the inequality. Same goes for 10, 5, that does not lie in the shaded region, so that means it does not satisfy that inequality. So therefore, the answer is B, 1 only, which is the point 1, 5. The fifth use case for using Desmos is when you're dealing with a system of linear inequalities. So we previously looked at how to use Desmos for a system of just linear equations, but we can do the same with linear inequalities. However, with a system of linear equations, the solution is just where those points intersect. For linear inequalities, we want to see where the shaded regions overlap each other. So let's look at this problem. It says, in the xy plane, point C is contained in the graph of the solution set of the system of inequalities above. Which of the following could be the coordinates of point C? So what are we going to do? We're going to plug in both of these inequalities into Desmos. And now we're going to identify what points lie within the shaded region. We can clearly see that the point 5, 10 is the only point that lies within that shaded region where both of the inequalities are basically overlapping. So our answer, therefore, is A. Use case number 6 is when we're dealing with linear and quadratic systems. So this is just when we have a system of equations where one of the lines is just a linear equation and the other one is a parabola or a quadratic equation. The question is probably going to ask us, what is the solution to this system? And since we have a parabola and a line, what are we looking for? Well, we're looking for where these two graphs intersect, and that is the solution. So let's take a look at this example. In the given system of equations, A is a positive constant. The system has exactly one distinct real solution. What is the value of A? So in this case, we know that the system has only one real solution, so that means that the parabola and the line only intersect once. So if you want to do this by hand, you can just set both of these equations equal to each other and solve for A, or you can use Desmos and instead of A, plug in each of the answer choices. So for example, with Desmos, we can just insert y equals 2 and then y equals x squared minus 6x plus 11, which is answer choice A. And if we do that, we get a line and a parabola. As you can see, the parabola intersects the line once. Now, if we look at answer choice B, it says that A should be 12. So if we plug in 12 for A, we can see that the parabola and line never intersect, so B cannot be right. Now, if we plug in -4, which is answer choice C for A, we can see that the line and the parabola intersect twice. So we know that that's not the solution. So C is out. And lastly, we have D, which is 8. So if we plug in 8 for A, we can see that the parabola and line intersect twice, which we know is incorrect. So therefore, answer choice A is correct. So that's all the popular use cases of using Desmos, especially for the algebra questions on the SAT. If you're starting your SAT prep journey or you feel stuck at your current score, go watch our free masterclass, which also comes with a free guide. This is going to walk you through mistakes to avoid, the best way to start SAT prep, and the 3-step process that we use to get our students results like this.